Hey friends, today we're going to add a little bit of work to what we were doing on the last time we met, which was Friday. I'm going to add a couple problems to the homework that are due on Wednesday, and I'll be around during class if you have questions about it, but I thought I could probably do this one asynchronously for people who just wanted to get it done and not worry too much about it. We're going to start adding stuff on the outside of that trig function and additions on the inside. And I know how insane this probably looks to people who are seeing this for the first time, so I just want to start by comparing this with something you're probably familiar with, though it's been a while, probably freshman year or maybe even 8th grade when you saw something like this. But you learn something about the way these work, and if I were to ask you guys, how does this graph shift? Maybe you don't remember off the top of your head, but hopefully you do know that something like this would shift 2 to the right, and it would be up 5. And if you don't believe me on that, and when I say move, what I mean is like we have a basic graph of y equals x squared, which is this U-shaped parabola deal. And then if I put stuff in there with the x in the parentheses, that's always like a left-right shift. And it's always the, always the opposite of the way you think it should be. And the number on the outside that's added or subtracted is an up-down shift. And it's always exactly what you think it would be. So if the normal graph of x squared looks like this and the vertex is at 0, 0, this one would be shifted 2 to the right and up 1, 2, 3, 4, 5, and it'd still be the same basic shape that I cannot seem to draw well today. But if you don't trust me on this one, feel free to open up a Desmos graphing calculator and then put this function in, and you'll see that it moves 2 to the right and up 5. And if you're really feeling adventurous and you really still don't believe me, type in y equals x plus h squared plus k into Desmos, and when it asks you if you want to add sliders, say yes, and then you can move h and k around yourself and see that as you change h, the graph goes left or right, and going positive makes the graph go left, going negative makes the graph go right, and changing k makes it go up or down. This is the same type of thing. The things inside of here, well, we already know what this does. This is going to affect the period. This is going to like shrink that graph down or stretch it out like a spring. This is going to move it left or right. Not quite what you'd think necessarily. If you're thinking it'll go negative pi over 4, that's not exactly 100% what happens. We'll talk about what happens. But this goes left or right. And then this number on the outside, we always put it in front with trig functions for some reason, but it does the same thing as this does. Like when I was learning this for the first time, the first thing I would do was rewrite this so that this number was on the end, just because it matched up more stuff I understood. So I would like take a minute to mentally rewrite this as negative 2 cosine 2 pi x plus pi over 4. And then I put the plus 4 over here just to remind myself that this is going to stretch it. This is going to have some kind of effect on the left-right motion. And this is going to move the graph up 4 units. So in the next video, now that we know what all these numbers do, I'm going to explain how to pull this thing together and graph it correctly. But I just wanted a quick review of how function transformations work, and that's what this was. So now, next video, let's look at how to graph this thing and use what we learned last Friday, plus what we learned 4 years ago, I don't know, whenever it was, to figure out how to do this thing. It's going to be a blast.